So what we're going to take a look at today is what's called operations on matrices. And we'll talk about the real-life applications tomorrow in class, but the objective for the day is to add and subtract matrices and also multiply matrices by a scalar. So looking at this, ignore that typo right there. Shouldn't be two S's on equations. But what I want you guys to do is pause the video now and give a shot at the do now. Alright, so the do now on the top of the guided notes, give that a try. Pause the video first. Alright, so looking at the warm-up. First, we're looking at rows and columns for everything that we're going to work with today. Remember, rows go left and right, and columns are going to go up and down for all of these. Now, if I take a look at this, the first question is saying identify the number in the first row, third column. So my first row would be here, and in the third column, that number should be 42. Now for the second question, what number is in the third row, first column? Third row would be down here. First column would be 4. Okay, that's going to be really important for everything that we do today in terms of matrices, because what a matrix is it's a rectangular arrangement of numbers, variables, expressions, or symbols contained by brackets. So what you're going to see is things that look like this. Okay, we're going to have brackets, and we're going to have a bunch of numbers on the inside of them. Now, the thing that confuses a lot of people about matrices is when we look at a matrix, we're going to have 2, 3, 4, 5. Say these 4 numbers. Now, if I look at these 4 numbers have nothing to do with one another right now. They're separate entries, we call them. Okay, each item in here is called a separate entry. Now, the 2, 3, 4, and 5 do not relate to one another. We don't add them, we don't subtract them, we don't multiply or divide them. They're actually separate. Just it's a collection of information within these brackets. One last piece of information before we actually move into some different things about these is dimensions of matrices. So how we can describe matrices is by the number of rows and columns that we see of information in here. So if I take a look at this, what we have is 2 rows by 2 columns. So the dimensions of this matrix would be 2 by 2. We're going to always say rows by columns. So another matrix, for example, would be something like 1, 2, 3, 4, 5, 6. Again, all of these numbers do not relate to one another. The dimensions of these would be the number of rows, which is 2, by the number of columns, which is 3. And guys, please ignore the door that keeps opening and closing. I have some rude colleagues, so they're just continuing to disrupt this video and take away some of the knowledge from you guys. But it's okay. We should all forgive them. Alright, so moving on to the next piece. When we look at things, matrices that are going to be equal to one another, it's when 2 matrices have all corresponding entries that are equal. So if I take a look at this 5 corresponds to the 5 over here because it's in the top left corner or first row, first column of each of these matrices. Same thing with the 0, and those are equal to one another. Even these. Negative 4 over 4 is equal to negative 1. They may be in a different form, but if I actually simplified this on the left-hand side, it would be equal to negative 1. And again, those entries correspond to one another. Same thing with the 3 over 4 and the 0.75, and those two things are equal. The only way we could say they're equal is if each corresponding entry is equal. Now, when we add and subtract matrices, basically, guys, all we're going to have to do is it's the same exact thing as addition and subtraction of numbers. It's just a different format of it. Alright, but one key thing. 2 matrices can be added or subtracted only if their dimensions are exactly the same. Okay, because you need to basically, we're going to add or subtract each of the corresponding entries. If they're missing something like that, then we're not going to be able to add or subtract them. So, for example, if I were given this matrix, 1, 4, 5, 7, 9, and 10, and I tried to add that with 3, 7, 9, 5. If I take a look at these 2 matrices, I see right now the dimensions are different. This is a 2 by 3 matrix. This is a 2 by 2 matrix. Now, when we actually go through and we add these, we're going to add the corresponding parts. So, first row, first column would be added with first row, first column of the second one. Same thing here. First row, second column, first row, second column. The problem is here, we don't have a third column over here, so we'd have nothing to add it to. So this would be something that we cannot do. And we'll talk about how we're going to address that tomorrow. Now, here are examples of matrices that we will be able to add and subtract. So these two matrices, we see we have a 2 by 3, 2 by 3. We're going to be able to combine these two. Now, all we're going to go through and do is we're going to subtract, because we have subtraction, each of the corresponding parts. So my answer, when I look at this, if this is a 2 by 3 matrix and I'm subtracting a 2 by 3 matrix, my answer should also be a 2 by 3 matrix. So, top left corner, alright, first row, first column, I'm going to subtract these two numbers. 1 minus negative 4. Next, I'm going to do negative 4 minus negative 2. That would be first row, second column, minus negative 2. Last but not least, I'll have 5 minus 1 in the first row, third column. And I'm going to go through the same thing in the bottom. 2 minus 0, the corresponding entries are going to be combined. Here, we'll put a star next to this one. 0 minus 1. And then last but not least, we'll do a little U on the bottom. Negative 8 minus 5. Now my answer is just going to be all of these operations actually done. So 1 minus negative 4, remember minus and negative would be, those would cancel each other out, become a positive. We would have 5. Negative 4 minus negative 2, same exact thing here. These two would cancel. We would have negative 2. 5 minus 1 would be 4. 2 minus 0 would be 2. 0 minus 1 would be negative 1. Negative 8 minus 5 would be negative 13. So my answer of these two matrices combined would be this matrix down here. Okay, all we did again is we just subtracted the corresponding parts. We would do the same thing with addition. So I'm going to add these two things. Again, this is a 1 by 3. 1 by 3, we can combine them. We're going to add the corresponding parts. 2 plus 1. Then that second column, we're going to have negative 5 plus negative 2. And in the last one, we're going to have negative 3 plus negative 3. Okay, same exact thing. 2 plus 1 would be 3. Negative 5 plus negative 2 would be negative 7. Negative 3 plus negative 3 would be negative 6. All right, and again, our answer should be a 1 by 3 matrix for this. Now, the last thing we're going to look at is what's called scalar multiplication. Scalar multiplication is going to be when we multiply every entry inside a matrix by some number. It's really like distributing, where we're going to have, you know, if we had something like 2 times x minus 1 and x minus 1 was in the parentheses, how we distributed the 2 to both terms, it's going to be the same exact thing with a matrix. Now, what it's going to look like with a matrix is it's going to have a 2 on the outside, and we'll have all of the corresponding parts. Now, the 2 is going to multiply to everything on the inside. We'll multiply 2 to all of the entries of the matrix. So we would have 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, and 2 times 6. Alright, and this really, we can do scalar multiplication no matter what the matrices dimensions are on the inside. Alright, and we would have 2, 4, 6, 8, 10, and 12. Alright, really, all it is the same exact thing as distribution. Now, the kinds of questions that you're going to have to work with on the worksheet that's going to follow is it's going to be a combination of the things. And it's going to be the same exact way we would solve simplify any other problem, where we're going to look at PEMDAS. So if we think about PEMDAS, multiplication always comes before addition and subtraction. So I'm going to have to use this 2 and this 3 on these matrices and actually multiply through first. So again, the 2 on the outside means I'm going to distribute it in. 2 is going to multiply all of these numbers, or all these entries. I would have 2, 6, 8, and negative 4. That's an ugly bracket. Alright, we're going to add whatever happens when we distribute the 3 through all of these terms. So we would have 3, 15, negative 3, and then 3 times 0 would be 0. Alright, now it just becomes an addition problem, and all we're going to go through and do is add the corresponding parts. 2 and 3 would be corresponding. That would be 5. 6 and 15 would be corresponding, and those two together is 21. 8 and negative 3 would be corresponding. Those two things would be actually, that could be a little confusing. I will add those two together. That'll be 5 as well. And then negative 4 and 0 added together would give us negative 4, which would be our answer. And again, we can add these two things together because this was a 2 by 2 matrix, and this was also a 2 by 2 matrix. The last thing that we're going to look at is if we're given a table like we are here about public school enrollment, we can make a matrix, and this is what computers really do to store information, because a lot of the time they don't care about these, right? They don't care about the titles. What they care about is the information that's put in here. So how we're going to transform this into a matrix is we're really only going to take the numbers. We're going to look at these, and really it's just going to be a matrix with these entries within the brackets. This is the first row, first column, 27.1. Second row, first column, 12.3, and then 11.1. And the same thing on the other side, we have our, still in the first row, second column, 3.1, 1.0, 3.0. It's really like taking this information and inserting it into Excel, which if you look at Excel, sometimes it kind of looks like matrices when we're actually inputting the information into the cells. Now, looking at this, the dimensions of this, again, we count the rows. That would be 3 by the number of columns would be 2. Alright, so that would end up being a 3 by 2 matrix. Now, the last thing you guys are going to have to do, there's a video I attached on Google Classroom. Just take a quick look at it. It kind of goes over the real-world applications of matrices, which we're going to go in depth in for tomorrow anyway. But after this, what you guys have to do is complete a worksheet on actually applying these things. So adding, subtracting, multiplying, dividing. I didn't do any examples for you guys to actually go through today because I feel pretty confident in the fact that you guys are going to be able to add, subtract, and multiply these things. It's just a different format for doing it. So if you have any questions, by all means, work together on this. But we'll go over everything in depth tomorrow. See ya.